Hello everyone, here is how I love geometry. I'm Mr. Chao. This problem is from 2006 AMC12B, problem number 23. The problem says triangle ABC is an isosceles right triangle, and in the triangle there is a point P. To the three vertex distance is PC6, PB7, PA11. So the problem wants us to find AC. How long for that? Its form will be like S equals square root A plus B square root of 2, and finally A plus B is how much? So this problem we have when we just read the problem is normally or regularly we will find, we can use coordinate system and use the formula of distance to solve the equation, right? So let us say this side is S. So say P, the coordinate, let's say X and Y. Then we can easily to get X squared plus Y squared. We will get the coordinate system. C is the original point. Then CA is the X axis and CB is Y axis. So we will get X plus Y, X squared plus Y squared equals 6 squared, right? Here is 6, here is 7, here is 11. This is point P, and X minus, so here is S0, A, and B is how much? B is 0 and S. So X minus S then squared plus Y squared equals 11 squared, and X squared plus Y minus S parentheses squared equals 7 squared. We have 3 variables, right? And we have 3 equations. Then we can solve S. This way, no problem, but it needs a strong ability to solve this equation. We need a lot of calculation. Okay, that's one way or one idea. Second idea, we should use a little trigonometry, because if we say this angle is alpha, and of course this is the complementary angle 90 degree minus alpha. So in the triangle PBC, that we can use cosine law, we can use the cosine law. Like 7 squared this side, the square of this side equals S squared plus 6 squared minus 2 times S times 6 times cosine alpha, right? And in the triangle ACP, and here is triangle PBC, and now the triangle APC, right? And we need to use this angle. So 11 squared equals 6 squared I'm sorry, I got allergy. Plus, here is S, so plus S squared minus 2 times 6 times S times cosine 90 degree minus alpha. So from these two equations, you see, cosine alpha and cosine 90 degree minus alpha, they have relationship. We can use this as to represent here cosine alpha. You can get how to cosine alpha use s to express, and here also we can use s to express, because cosine 90 degree minus alpha is sine alpha, right? Sine alpha, just cosine alpha, sine alpha. We can use this to express the sine alpha. Now we can use the identity trigonometric, the basic square alpha plus cosine square alpha, they are equals 1. Then you can solve s, right? No problem. But all of these two ways need a strong ability for calculation. Okay, now I just want to introduce another idea or another ways. This way is not so regularly, because normally sometimes we can use it, especially when we got the problem like this. There is a point in a equilateral sometimes and got something, and sometimes in a square, like there is a point here inside and then some other condition or giving information, and another case just like this problem in a right triangle, in a right isosceles triangle and a isosceles triangle. So there is a point, and this situation we can use a very special way. What's that way? We can rotate this P, this point. So let me show you how to use this. I just extended AC, and then let me see A prime, then we can connect it A prime B, and rotate how much, what's the angle? We can rotate this CP. If I say this angle is up, then this will be 90 degree minus alpha. We can rotate CP alpha. Why? Because if we rotate counterclockwise degree alpha, and we know 90 degree minus alpha plus this alpha will be 90 degree, right? So we can get a new right triangle, and the length is the same. So we will get the P prime, and let us collect this P prime and the C. Now we know if we connect A prime, P prime, we know, and also connect B, P prime, right? So we will find a lot of congruent triangles here. So this is also 6, and this is a right angle, and if this is 6, and so this is alpha 90, that's alpha, that's 90 degree minus alpha, right? So this side is S and 90 degree minus alpha, so this side is 7 and this side is 11, because this triangle is congruent to this triangle, right? No problem. Now how to solve this BC, right? we want to get this BC. Why we want to think about rotate? Because under all of this situation for the equilateral triangle, square, and isosceles right triangle, when we rotate, we just put the given information here. The most information is right angle and BP, PC, PA. If we don't rotate, it's not easy to use all of this information. If I rotate and got another like a reflection isosceles right triangle, and we can put all of this given information into a new triangle, just like here is 11, 7, 6, and 6. And we know P prime and P, this is a new isosceles right triangle, and this is 7, this is 11, and we know P prime and P 6 and 6 here must be, this is 6, this is 6 times square root of 2, right? Now, if we wanted to know to get the final answer, there is one way we can, because we know this side is 11, this side 6 square root of 6 times square root of 2, here is 7. We can use the cosine law to calculate the cosine value of this angle BP P prime. And we know this angle, I mean angle P prime P and C is 45 degree, right? We know that. So we can get in the new triangle BPC, we can use the cosine law, and BC squared will equals PB squared plus PC squared and minus 2PB times PC times cosine angle BPC. And the cosine angle BPC, we can use this formula. Cosine alpha plus beta equals cosine alpha times cosine beta minus sine alpha sine beta, right? Yeah, no problem. We can use this way to calculate to get the final answer. But sometimes, if we pay more attention for the number of these triangles sides, we may find a special angles. So here, I just know 6 times square root of 2 squared plus 7 squared equals how much? So 36 times 2 plus 49, so equals 70 plus 49, so how much? 121. 121 equals 11 squared. 11 squared, it means this side BP prime squared. So this angle, it means P prime PB is a right triangle. So the problem now becomes too simple. And this angle is 45 degree. We know this one, right? So it means angle BPC equals 90 degree plus 45 degree. And this is the Pythagorean theorem, right? Everyone knows that. So 135 degree. Then we can use cosine law. S squared equals 7 squared plus 6 squared minus 2 times 7 times 6 times cosine 135 degree. So this is 49 plus 36 minus 84 times, right? So what's that? That's 85, right? Minus 42, because 42 square root of 2. So as we can use the form as then s equals square root of 85 minus 42 times square root 2. It means a equals 85, b equals 42, then we got a plus b is 127, right? That's it. Yeah, I have explained detailed all the details how regularly we use these two ways, right? Yeah, also we can get the final answer. And in some special triangle or quadrilateral, we can use rotation way. This way can mix all the given information together into a quadrilateral or a special triangle. And normally you will find the triangle is very special. Like here, you can find it's 90 degrees. Sometimes maybe is 60 degree. Oh, and another angle is 45 degree or 30 degree or 6. Yeah, some special angles. Then you will easily to find the final answer. Okay, let me stop here. I hope you can love it and enjoy it. Thank you.